Hey everybody, this is Jace at ARM US, and I'm here today with the gentlemen at SPH Engineering to show us a couple of kind of unique payload offerings and stuff that they've been working on and stuff that we're bringing to our customers. So I'm here with, introduce yourself.
My name is Travis Claypool with SPH Engineering.
Right, so what we did today is we actually had some customers here. We were doing some demos and taking a look at kind of what these sensors are, what they're capable of, what they actually do. And we have a couple things here, but first off, I think what we want to start with is kind of the brains of the organization is the SkyHub.
Correct.
Tell us a little bit about like what actually is SkyHub, how do these integrate with it?
Yeah, it's a great question. Typically when you're flying your drone, you're going to be flying it with a controller and collecting data using a camera or anything else. The SkyHub itself is sort of like your onboard pilot. It will take and understand data that's coming from any one of these special payloads. It'll also help drive the drone in those circumstances where you need to kind of pre-program and make sure you're flying really low. So it's sort of the computer behind the computer is the best way to kind of put it. The SkyHub is what integrates everything together and allows us to use these really cool payloads that we have out here.
Right, and of course when we're bringing in complex payloads and that kind of stuff, we kind of need that intermediary. We need
Correct.
to have a payload that interacts with that, which also interacts with the drone aircraft itself and the remote. That kind of brings everything together so that everything
Absolutely.
can talk to each other, right? So with that, that's kind of the hub there. Let's just go through each one of these at a time. We have a couple of different payloads here. First off, let's talk about the laser.
Yes, so that's the Laser Falcon. That's the methane gas detection device. With that, you can fly approximately 20 meters off the ground, and it's going to start to give you concentration values. Typical use case might be testing for methane in a landfill, or possibly running down a corridor with a pipeline, seeing if there's any leaks in that pipeline. Often these things are done with larger vehicles like a helicopter or something like that, but these are great because we can put this in areas that a helicopter could never get with our drone.
Right, and well, the other half of that also, as it always is with the drone world, is safety.
Correct.
We're not putting someone up in the air doing all that, but we're also saving a lot of time and we're saving a lot of money.
Absolutely.
By doing stuff with a much more efficient method of actually collecting that data as opposed to having an aircraft in the air. So that's a big difference there.
Certainly.
Next, moving on to this guy right here,
Yes.
which is?
So this is ground penetrating radar. The typical way this might be used in the past, some of your customers might know that it's drug on a sled across the ground or in a cart, which is obviously, you have to have somebody there on the ground moving that thing, and that can get expensive. It's one of the really cool things when you start to integrate things with SkyHub. This has to be close to the ground. Dragging it on the ground is actually a great way to collect that data, but there's trade-offs. With the SkyHub and our terrain following, particularly the true terrain following, you can get very, very close. We're talking a meter off of the ground so that this thing's collecting data, not seeing a whole bunch of reflections or anything like that.
The other thing about this is, though, too, is when we picked it up, it was like, I can't believe how light this is.
Incredibly light, yes.
It's ridiculously light. So you might see a payload like this and think, oh, you know, that's really going to drag down on my flight time on my aircraft, where none of these are terribly heavy. They're not that much of a drag on it. So really, it's not much of a consideration when you're talking about this type of payload, which again, you know, that's commonly a problem. You have an advanced payload or something like that. Usually it's like, yeah, you can do this, but you're not going to fly for very long. And that's really not an issue with these types of payloads.
No. It's, yes, very light, and all your common. You don't need any heavy lifting drone or anything like this. Many of the common enterprise drones out there will fly any of these payloads just fine.
Yep, absolutely. But use cases for this?
Yeah, so use cases down in Texas, where I'm from, they're actually looking to find abandoned wells and underground structures, so underground infrastructure, pipelines, things like that. They provide a reflection, a signal that the ground penetrating radar can see. So whether it's a construction site looking for old abandoned wells out on a farm or something like that, or you know, we're looking, I had heard that there was some researchers actually trying to determine the size of beats underground looking at the reflection. I don't know if they were successful or not, but that's the really neat thing is once you start adding technology to things and creating opportunities where there weren't before,
it starts to snowball.
It does, yes.
Like, oh, I wonder if we could use it for that.
Right, yeah.
And, you know, we had some discussions with some people today talking about some recovery operations, that kind of thing.
Yes.
For public safety, that kind of stuff. Absolutely has a realm of possibility with that type of thing.
Definitely.
Perfect. Again, so ground penetrating radar, let's move on to magnetometer.
Yes. So this magnetometer, speaking of public safety, this thing will, it's kind of a unique setup. It looks kind of funny, but it actually hangs just underneath the drone. And this is designed to be very, very close to the ground as well. The idea here is we're looking for underground pipes, we're looking for underground infrastructure, but also this is being used to find unexploded ordnance and mines and things like that out in a field. If it gives off some sort of a magnetic signal, we're probably going to be able to see it and map it and provide the data. And again, it's very important to not get data from elsewhere, which is why we have to fly close to the ground. And this whole system sort of enables that, where before you wouldn't want to put somebody in a minefield and have them run around and try to find out where it's at.
Right.
With this, we can fly close and still do that same thing, make everybody safe.
Right, and that's what just about anybody will tell you is when it comes to data is how close do I have to fly? And you always say the closer the better.
That's right.
Right, we're going to get higher fidelity and all that kind of stuff. And this, again, this type of payload, this type of data collection just speaks so much to, you know, we're at a point where there's been so much infrastructure over the years and stuff like that, and there could be infrastructure that's 50, 60, 70 years old, still hanging out under the ground somewhere, and who knows where the original maps are or anything like that. Nobody knows where this pipe is actually buried at, type of thing.
That's right, yes.
So this type of stuff, as we digitize so much of the world, really, you know, instruments like this are going to give us that capability to be like, okay, let's find out what's actually out there, so that we can make good decisions about what we're trying to do.
That's right. There was poor documentation. It's not a new thing. Things have been poorly documented for years.
Sure, but we're trying to make up for
Absolutely,
that.
Absolutely, yeah. That's one of the really cool things. If we can add data, data is collected and then turned into information you can use to make decisions. And that's really what's most important here is how can we help collect the data that you need to make the decisions for your workflow or your research or whatever it is.
Yep, absolutely. So magnetometer, then finally, I always have a trouble saying this, bathymeter?
Bathymetry.
Bathymetry.
Yes,
okay.
yes. So this is an echo sounder, an echo logger. And the idea here is we drop this just into the surface of the water using the drone. It's on a very long tether. And it's sending those pulses down and receiving a depth information so that we can map the underside of a pond or a lot of times in mining, tailing ponds, or for dredging, like in New Orleans, I know they try to map a lot of this stuff with bathymetry because they've got to oh gosh, I'm blanking on the name, but they've got to go in and dredge out all those causeways and things like that to make sure that ship traffic can come through. This is a way of understanding that information with, again, you don't have to put somebody out there. So
right. Well, at that, and again, we're talking about efficiency. I mean, a time before you have an instrument like this, I mean, you're draining an area so that you can look at it for a little while, and you know that becomes costly, that becomes an issue. So being able to do those things, and kind of speaking to this is that, and we're talking about the Sky Hub, is that what really brings this all together.
Correct.
And we noticed about flying this today is, yeah, we have some unique things here. When you're taking this off, when we saw that it takes off, it kind of has its own kind of groove to it, right? You need to take off and land in a specific way. It's nothing terribly complex, and the same thing with the magnetometer.
That's correct.
That is a specific thing that you need to be able to do. However, the hurdle to actually collecting the data is so small.
Right.
And that's usually kind of the hang up that a lot of people have when they talk about these types of payloads that aren't what you might call traditional payloads, like a thermal sensor or orthomosaic imagery or stuff. You know, that stuff is very streamlined, it's very easy, but usually people get a little they get a little freaked out when, oh, we have something that's very unique or something that's very different, and that usually kind of is the tripping point for a lot of people. All right, so now finally, the last thing we want to talk about is some of the other integration of the hardware that you have, talking about terrain follow and that kind of stuff. Tell us about the rest of this hardware that you have.
Yeah, so every pilot needs a good set of eyes and needs good altimeter. Our Sky Hub uses one of these two options here. One is radar, so it's bouncing waves off the ground. The other is laser. The reason that we have two is it depends on your use case application. Lasers don't work great over water. Radar works great over water. So it just depends, but the whole idea is this true terrain following allows us to get very close to the ground, and it's the actual ground. Many times in mine sites or other places, a hill might now be a hole, and we need to be able to understand what that terrain looks like now, not 6 months ago or whenever they flew the satellite.
Yeah, whenever that happened to be. And that's the point, is it's, you think about it's reacting to something that it's detecting on that site on that day, as opposed to downloading a random topographical or something like that, or even having to go to an area, capture it first, and then generate your own, and then go through with the data. You know, this doing it in real time, more or less reacting to that day. That's a big difference when we're talking about this kind of thing.
Now, I do want to highlight, too, that it is entirely possible to do all that with the UGCS Mission Planner. You can do those things if it's required, but with the true terrain following, it's
usually not necessary.
Not as necessary, no.
Gotcha. All right, thanks again for the guys at SPH Engineering coming out today. It's been fantastic. We've loved to see these applications and that data sets. But if you want more information about any of these offerings, make sure you get in touch with the team at RMUS. You can hit up sales@rmus.com or find the rest of our contact info right on our site. And again, thanks so much for coming out today. We really appreciate it.
My pleasure.